everyone, in this video I'd like to talk a little bit about solving an equation with a radical in it. Now, one of the first things that comes to mind is to get rid of this radical. It's quite inconvenient to have the radical in there. So, one idea might be to go through and square everything. And that's not a bad idea, but the problem is if we do this, on the left-hand side, we'll get a square root of 3m minus 5 squared, which is fine. But then when we FOIL this out, we're going to get negative 9 times the square root of 3m minus 5, and then another 9 square root of 3m minus 5 plus an 81. And that's going to be counterproductive because we're still going to have a radical in our equation. And so squaring both sides didn't really get rid of our radical. In fact, it maybe made our equation a bit more complicated. So just an alert about that step. Why did I get those terms in there? If you remember, FOIL stands for first. Oops, I wrote that wrong. Let me just fix my typo for a moment there. It stands for first, outer, inner, last. So that tells us something about the multiplication that goes on. And so just writing this out, it was the square root of 3m minus 5 minus 9. And squaring at 3m minus 5 minus 9. So if we do the first terms, that's where the square root of 3m minus 5 squared came from. If we do the outer terms, that's where the negative 9 square root of 3m minus 5 came from. And then the inner terms right there, we get another term that looks like 9 square root of 3m minus 5. And if I sound like I'm bored, that's because I am, because this is a very tedious process and I don't recommend you do this. But it is tempting to do it, which is why I took a moment to explain what would be involved if we went that way. So it's tempting to go that route, but we don't want to do it because it's not going to make our life any better. So I'm just going to put a big red X through that. We don't want to proceed that way. So let's try another approach. So I'll write here another approach. So the another approach, and I'll copy down the problem here. We had a 3m minus 5 minus 6, minus 9 equals 6. What we want to do is we want to move that 9 over to the other side first. So if I add 9 to both sides, that's going to be really lovely because now on the left-hand side, I just have 3m minus 5. And then the 9s go away. And on the right-hand side, I have 15. And the reason that this is so lovely, and now I'm getting excited, is because if I square both sides of the equation now, I'm going to get rid of that radical sign. And this is really great. My life is going to get a lot better by doing it this way. So on the left-hand side, if I square the square root of 3m minus 5, I'm just left with 3m minus 5. And that feels very satisfying. And on the other side, on the right-hand side, 15 squared is 225. So that wasn't too bad. And now we want to solve for m, so I can add m to both sides. So those go out. On the left-hand side, I have 3m. On the right-hand side, I have 230. And the last thing we need to do is divide both sides by 3. And 3's go away, and I'm left with just an m on the left-hand side, and on the right-hand side, 230 divided by 3. And I'm going to leave this in exact form. Now, I could come up with a decimal approximation, but exact form is always better for your final answer. And the reason I say that is because, if you're working on an engineering team or some sort of data science team and you have a value, and then you're going to pass your data on to somebody else on your team, and they're going to use that number. If you've rounded off your answer, you're going to start to introduce round off errors into the whole team project. So you want to keep everything in exact form until the very end of everything you've ever done. So unless somebody says round it to the nearest decimal or the nearest cent or something like that, you want to present your answers in exact form, no decimals, just keep everything very precise like that. So I'm going to leave it like that. That's my final answer, 230 divided by 3. And the thing I'm going to do at this point is then I need to go ahead and check my work. And the reason that it's important to check the answer is because we went in here and squared. So sometimes you can introduce extraneous roots because we squared the radical here. And so it's always good to just check the work. So to check the work, I'm going to plug that answer back in. I had in my original problem 3 times m, which I'm thinking is 230 divided by 3. So I'll plug that in. Minus 5. Minus 9 off the back end, and I want to know if that's going to equal 6. So doing a little calculation here, I have the square root of 230 minus 5, so that's going to be 225 minus 9, and I want to know if that's equal to 6. On the left-hand side, the square root of 225 is 15 minus 9, and indeed that is equal to 6, so I'll give that a check. I am confident that this is my final answer. Now, we can go over here and check that in Wolfram Alpha. So I'll show you how to check that with technology here. If you type this in, solve the square root of 3m minus 5 minus 9 equals 6, you will get a solution here. So that's always a good way to check your work as well.